So this is number 10 from the Chapter 5 quiz review. And in this problem, we're given a table, and this table represents the velocity in meters per minute of Joanna's jogging. And so it says approximate the value of the definite integral from 0 to 40 of v of t dt using a right-Riemann sum with the 4 subintervals. So again, whenever I do a Riemann sum from a table, I like to draw the picture. Just makes my life easier, I think. So at 0, we're at 0. Then at 12, we're at 200. So not in any way to scale here, just giving me something to be able to visualize. At 20, we're at 240. At 24, definitely not to scale here. We're going to be at negative 220. Oops, excuse me. Negative 220. And then at the end, 40. We're back up at 150. So I draw my right endpoint rectangles. The right endpoint of my first interval is at t equals 12. The height there is 200. The right endpoint of the next interval is at t equals 20. The height there is at 240. 24, we're at negative 220. And then at 40, we're at 110. So I just then need to add up each of these different areas, the area of each of these different rectangles, and get my answer. And I believe I get 5,840, if my math is right. And because my heights of each of my rectangles are meters per minute, and my widths are in minutes, then this is in meters. And this thing is Joanna's displacement on the interval from 0 to 40. Now part B, before we jump to part B, we know that it's displacement because we know that the definite integral of velocity represents displacement, because if we did have a function, what we would be doing, we would take our, I'm sorry, I said if we did have a function. We do have a function. If we did have an equation, we would take that velocity equation, we'd take the antiderivative, which would give us the position equation, and then we would plug in 40, we would plug in 0, and we would subtract those things to get our displacement. Now part B changes the question slightly, just slightly, and says, all right, now put this absolute value in your definite integral. What's that going to do? Well, it's only going to do one thing. It's going to change this negative 220 to a positive, right? Because that's what absolute value does. It changes anything that's negative to a positive. So all it's going to do here then is take this guy and make him a positive 220. And so now when I add up those rectangles, instead of subtracting all this area, I'm going to be adding it. And my picture is not to scale. These two things should be the same, just one is negative, one is positive. So when I add all that up, I get 7,600. And again, still meters because my units still cancel out in the same way. Now what does this one represent? Well, what we did is we essentially didn't allow positive and negative area to cancel out. We just treated it all as if it was positive. Well, that's the definition of total distance traveled. So that's what that is. Total distance traveled. Because again, when when we do displacement, there's some positive and negative movement that might cancel out. When we do total distance traveled, we just change the signs of all those motions and we don't allow them to cancel out. We just treat it all as if it's positive. All right, last one. Now we switch from talking about Joanna to talking about Bob. So Bob is traveling along the same path, and he has this different function. Instead of being given a table of values for our function, we're actually given a equation, so that's nice. And it wants us to evaluate the definite integral from 0 to t of Bob's velocity. So not too terrible here, just a little antiderivative power rule. The definite integral from 0 to 40 of t cubed minus 6t squared plus 300 dt equals 1/4 t to the 4th minus 2t cubed plus 300t from 0 to 40. Give ourselves a little bit more room here. And if I plug all that in, I believe, if I did my math right, I get some big numbers here. 758,400. Again, this would be meters, because what we started with velocity and we turned that into the position function, which would just be measured in meters. And because there's no absolute value, it must represent the same thing as Joanna's did, which is just Bob's displacement here. Bob's displacement on the interval from 0 to 40. All right, that's number 10.